how to containerize our Spring Boot applications. Please welcome Melissa McKay.
Hello, hello. Hi, everybody. I'm just curious who on the audience is using Spring right now today? Everybody. This is great. How many of you are already containerizing your applications? OK, cool. There's many, many different ways to do this. You're in the right place just to talk about a few different ways that you might consider. This is more going to be about evaluating the solution that you chose and what a developer might do in their day-to-day to decide what tool or what method to use. I will talk about a couple of things that you may not have realized that's happening under the covers to be mindful of and make sure to measure your risk when you use some of the tools that we talk about today. So we are here, Practical Guide to Containerizing Your Spring Boot Application. I use a lot of my background story here because way back when I first started using containers and learning about Docker, things like this, I had to go through all of these steps manually. I didn't have a lot of resources other than what was available online at the time. Since then, documentation has improved incredibly, so I really encourage you to go ahead and take advantage of those resources. And I think as we have a lot more experience under our belts, I think a lot of us can share stories of to-dos and what not to do. I know I usually talk a lot about Docker, and I am a Docker captain, and I talk about things that you might want to avoid when building Docker containers, especially when you're dealing with Dockerfiles. Just a quick background information. I like sharing this just so you know where I come from. So if you hear any bias or whatever, it might make sense if you know where I'm coming from. I am a developer first and foremost. I'm currently a developer advocate with JFrog. I'm going on my third year at this DevOps company. But prior to that, I was a developer, all the way from lowly intern to a principal developer at my last organization. I started to speak, really enjoyed doing that, and really wanted to get more involved in education, especially with a passion for new developers coming in. I have noticed that a lot of the crowds that I get involved in, we're starting to age a little bit. I've been counting my gray hairs, I know for sure. And I'm really concerned that we might not be doing enough to talk to the younger generation and maybe, going back to fundamentals and reminding all of us of best practices at the beginning. When you're talking about developers that are coming in from university, for example, they may not have had exposure to a lot of these DevOps tools that we're using today in our development environments. So it can be a lot like drinking from a fire hose for them. I just want to share some words of comfort that all of us have been there. We all need to take some time to remember how it was when we didn't know anything either, and give some encouraging words to those folks that are learning their path. If you've listened to any of my talks in the past, you'll notice that whenever I talk about containers, I refuse to use any graphics of shipping containers. That's boring. So I've used food, I've used bananas. Last year, my talk, Docker Do's and Do Nots, I used cats, pictures of cats for every concept. It's pretty fun. Today, we're using clip art. We're going back to fundamentals, and we're starting at the beginning. I wrote this book with a few of my colleagues. This was a time to do a lot of research for Java developers specifically on all of the tools that we need to be using in our daily work. This was a pretty extraordinary experience. They say you're better at teaching, or you're better expert at something if you've taught it. So this was a pretty big exercise for us to actually put in writing all of our experiences. And it basically brings someone up to speed about DevOps concepts from the very beginning and things that you need to consider as a new developer in this space. Notice there's a section on containers in there. I wrote that chapter. And then also continuous integration, that's something I'm pretty interested in. I do remember the days that was brand new to me when coming in as an intern, and I was surprised at how often I broke the build. It was pretty embarrassing, but I did learn a lot of making sure that I'm testing my code thoroughly and learning how to work in a team, which was extremely valuable. So moving on. First of all, if you're new to Java or new to containerization in general, we really need to, we want to learn how to do this. A lot of this is my own journey, like I said, and my hope is to get you a better understanding and starting place than what I had when I started out. There's going to be a lot more to learn after this. I hope this presentation inspires you to do some further research. I have one specific thing I'd love for you all to do homework on. But my focus today is just to give you a good foundation, at least where packaging your Java apps in containers is concerned. And rather than get overwhelmed with all of the options, understanding how to evaluate the solutions that you come across will be invaluable to you. I went out looking for a simple project to play with. That's the best way for me to learn anyway, is to start with something that's already out there and then tweak it, fiddle with it, play with it. That works really well. How many of you are familiar with Spring's Pet Clinic app? Only a few. I'm surprised. This is a very popular application. It's been out for a while. It's just sitting in GitHub, and I have a link on a later slide for it for you to explore. There's lots of different versions of this application. It's basically an online veterinary management system. You can keep track of pets and their owners and their visits, imagining you are a veterinarian. So pretty interesting application. There's a gazillion different forks, different versions of it, even in different languages. There's a microservices version. There is a monolith version. The one that I decided to play with was the cloud version because I was interested in containerizing this thing and how it was done. Now, before I go any further, I can probably skip this slide. A lot of you are already containerizing your apps, so you're already familiar with the basics. But if there's anyone out there that doesn't realize the difference between a container and an image, I'll use those words frequently. The container is the actual running application. It's on a server. It's actually been launched. An image is the blueprint for that running container. And a blueprint is usually what we keep in source control. That is likely going to be a Dockerfile when you're first starting out. We'll talk about other options as well. But when I was learning, I started looking at a Dockerfile. One other thing to remember when you're starting to learn something new like this, and this is actually something I learned from a keynote at a previous conference by Tom Cools. You might have caught his talk here as well. He mentioned that when you're learning something, it's good to limit what you don't know. So here I'm focusing on containers. I was familiar with Spring, familiar with Spring Boot, so that I was comfortable there, familiar with Java. So the moving piece in there is the container part, and that's what we'll be looking at. So today, a modern developer might go to ChatGPT. We've had a lot of discussions about this. I don't know what to think about this. I played with it a little bit today, just for fun, but I love the limitations here. May occasionally generate incorrect information or produce harmful instructions or biased content. And I guess what struck me most about this is it's how uncontrolled it is compared to the information that you get on the internet. At least when you're Googling for something, you might be able to check out who wrote the blog, who wrote the article, where is this advice coming from? Is it coming directly from VMware? Is it coming from Pivotal? Especially if it's something about Spring. You have some way of finding some authority on the subject. This seems like a free-for-all, but it turns out they give some fairly, okay advice. I say okay because this is generally what you would find if you Googled for this information. I don't know if you can see the question I asked was, how do you containerize a Spring Boot application? And it gave me some pretty standard instructions. Using a Dockerfile, you obviously need a project to start with. It even gives me a Dockerfile as an example. Tells me the commands to build and run this thing. Even gives me information about opening a port and how to view it on my local machine. Well, that's pretty cool. There's a few things in here that remind me of documentation that I saw in Spring's documentation. So for me, right away, that had a little bit more authority because I've seen it before. Now, I put a link here, and if you were to go to this link today, it's going to 404 on you, because what I love about the Spring community is they keep up with things and they modify their documentation, they improve it over time, and some of my complaints about this example Dockerfile have been addressed in the newer documentation. This one in particular, notice it's JDK 8, pretty old now. We're way beyond 8. But I'm curious, since a lot of you are using Spring today, what version of Java are you running on? Is anyone on 8? We've got a few. How about 11? Did you make the jump to 11? Okay, good. Anyone on the cutting edge on 17, 19? Oh, awesome, a lot of you. Okay, so there may be some more tools available to you since you're on later versions than there are for folks that are stuck on 8 and 11. For my particular research, I chose to use version 11. And specifically, when I tagged my version, I used the full version of 11. I actually moved this image into my local registry, and that's something that I argue for again and again. When you pull down one of these images, you really should be storing it locally. Don't always be going out to Docker Hub to get a fresh image. Just to reiterate how important that is, whenever you leave your dependencies, and I consider these images to be dependencies, so this is a parent image, whenever you leave that in the hands of a third party, it's not that the third party has ill will or anything or intends to mess you up, but occasionally that third party was going to have different priorities than you and your project, and they're going to do things that are good for them. For example, recently there was a little bit of a debacle. It just lasted a few hours with GitHub. And what happened was GitHub decided they were going to make their storage of release artifacts a little bit more efficient. What that ended up doing was regenerating a lot of these release artifacts, the stuff that automatically generates when you tag a release. Unfortunately, a lot of package managers out there assumed that this data, packages were immutable. And in order to check the security of these packages, there's always a checksum, right? Well, GitHub decided to use a different compression method. And I assume in order to save space, just to be more efficient, whatever the reasons, there was a miss in that communication. And a lot of package managers were broke, because now when they did the comparisons with the checksum, it alerts that there might be a problem with this dependency you're trying to download again. So even though it was an improvement on GitHub's side, it appeared as a security problem on package manager's side, all because there was a disagreement on what was immutable and what wasn't. So this is just one example of how you need to pull in your dependencies and keep control of your dependencies. Don't be constantly asking third parties for your stuff. It really is your responsibility to manage those. Just the end of that story is GitHub was very kind and reverted that change This is a hard problem to solve for them, so I'm curious what they're going to come up with going forward in the future. But hopefully with enough communication with everyone, we'll get a good solution in place. So for this particular one, I updated the base image from 8 to 11. That was the first step. And I'm using a full JDK image here, and also my own registry. And I built this application using the new Dockerfile and was successful. I was very happy. So here I am, I've got a good starting point. Now I'm at a good place where I can tweak, make different changes, try different tools, build these containers a little bit differently, and see how it goes. So lots of things to consider. These are things I listed out that I wanted to be concerned with. Most of the time, we're concentrating on performance, reliability, making sure that our application behaves as it's supposed to with an appropriate amount of memory and garbage collection behavior. Of course, we're also worried about build times and making sure that we have decent test coverage to catch bugs and stuff. And I've underlined and bolded dependency management here. I actually didn't. I'm telling you this should be underlined and bolded because we don't talk about this enough. Hoping that you know by now how important this is. How many of you have had to update your dependencies recently because of a security vulnerability? Yeah, good. Everyone's hand should be up. This should be a regular thing that you do, a regular, looking at your code. This is something we do already with just our Java stack. When you add Docker to your stack and add the container tools, you have a whole nother load of issues to be concerned with. The size of your image is one of those issues. I'll talk about why and why you might care about that in a sec. Of course, with version 8, earlier versions of 8, my first issue was memory issues because C groups didn't behave as expected with the earlier versions of Java 8. So I had a bunch of containers that suffered from out-of-memory resources all of the time. That was interesting to learn. But think about if you've already have all of your dependencies that you're bringing in for Java, now you've got dependencies like OS packages that are coming in with these containers, with these base images. So much more to be concerned with. Size of images. We hear about this a lot. It's not the most important thing in the world, but it is one good metric to go by. It is best practice to try to limit the size of your images as best you can. There's several reasons about this, but the reasons are basically the bigger your images are, the more difficult it's going to be to ship them around. Especially if they're ephemeral, if you have constant scaling activity, you need to be able to get rid of these containers that are running and then be able to launch them again quickly. That is going to involve pulling them in from a registry, a Docker registry of some kind, or an OCI registry. And the bigger these images are, just the heavy weight that is going to be and cause some issues. Another reason to consider size is generally the bigger the image, it implies that there's more stuff in it. There's more libraries in there. And we all know, anyone who's worked with Spring, we all know that we're probably sitting on a bunch of dependencies we don't even use in our applications. It's a convenience, and we pay that price every day when we use Spring. Not down-talking Spring. I love Spring. Use it a lot. But there is some costs that we have paid because of that. Speed. So I generally talk about continuous integration when I talk about speed. When you start to care about the speed of your builds, that's what matters. And depending exactly how your application is deployed, you'll care even more about speed. It's not necessarily the startup time of launching the container, although that's somewhat related. This is also about pushing and pulling the images across the network. It's of course, stands to reason that bigger the image is, the more stuff you have. So now you have, security issues as well. This really becomes important when you start to look at the processes that you have to roll out updates. If you want minimal downtime, as well as that automatic scaling of your services, you want these processes to be as fast as possible. So again, this is related to size as well. We all know what it feels like to suffer through long build times during development. I know as an intern, this was something I struggled with a lot way back when I first started. Really understanding how your build works, and now this includes Docker containers possibly, is really, really important. So if you're brand new to a team, you're ramping up on the project, make sure that you're paying attention, that you spend enough time in the beginning to understand how your build is actually working. A good example of a reason why is when I first started out, I got instructions for building this particular project. It was a multi-module Java project. I didn't understand the build. I just would make a change that I was interested in and use the automation for building on my local machine. The problem with doing that is this build takes 25, 30 minutes. It's a very, very, very inefficient way to work. Once I understood that how all of these modules were related and how this build actually worked, I learned that on my local development environment, I could change one module, only rebuild that module instead of the entire thing before checking it into continuous integration where that could actually build the entire thing. So just little things here and there that sometimes we forget to pass on to the younger generation, some tips on how to speed up your development. I touched on this already a little bit, and this is another reason to be concerned about size. It's security. It is very simplistic to think, but the less that you have in this container, the less chance you're going to have packages and libraries that contain vulnerabilities that you need to worry about. Things that can cause you problems by letting an attacker escape the confines of your container, and other risks that like leaking private data, for example. All of these, we're familiar with all of these. I think we've heard a lot of security issues in the last couple of years, so we're all learning more. We're all becoming better aware to prevent that. So this idea is just to reduce your attack surface area, and one way to do that is limit. Certainly don't have libraries and dependencies that you're not really using in your application sitting there just waiting to be attacked by someone with ill intent. Last reason, again about size, is money. Do you remember when, I assume everyone has a cell phone. This is pretty much the norm now. I actually remember not having a cell phone, if you can believe that. And I also remember getting a cell phone and understanding that every text I sent cost me money. So individual texts. This is how I feel we are with cloud resources right now. I really felt this way when I got my last, I'm not going to fill in the name, cloud bill. It was pretty surprising, and I was disappointed that I left some services running that I shouldn't have. So this is definitely going to cost you if you have bigger images, you've got more storage space you're taking up. You're going to be charged for that. So to be efficient, to be economical, keep them as small as you can. Docker layers. Like I said, understanding how your build works, you really need to understand the details on how Docker images are built as well. This means understanding how layers work. Since a lot of you are building containers already, you probably have a good idea of what this means. But these layers correspond to instructions in the Docker file, and the more instructions you have, the bigger your image is going to be, because basically the next layer is going to be a diff of the previous layer underneath it. So you can see with each instruction, we're building more and more into our final image. That understandably increases its size. Taking a look at that first line a little bit closer, that first from instruction, Docker images are built based on existing images. I'll show you an example where there isn't a parent image. It's called Scratch. I'm sure you've all have run into that. But this first line is a parent or a base image, and technically, this parent or base image could even have its own parent or base image. So you can easily be building a huge Docker image without realizing it, just because you're bringing in a base image that you're not aware of all of those pieces and parts. In this case, our image built from this Docker file would be based on that full OpenJDK 11 image. That's pretty heavy, actually, and we'll show an improvement to that in a second. So how do you really know what's going on? How are you able to analyze your images and figure out exactly what's in there? Just by looking at a Docker file, it's probably not enough. You need some tools. You could go through the effort of building the image and then execing into the image and exploring around, but there are some other tools that can help you figure out how your images are built. Most commonly, you're going to see base images that are official images sitting in Docker Hub. And this is an advantage just because you know that there are trustworthy folks that are maintaining these images. You can offload a little bit of that work to other parties that are interested in maintaining these images and keeping them updated, rather than, picking an image up off the street that you don't know where it came from. One other example, I suppose, where you wouldn't use a official image, for example, you may use, a pattern I see is to have like a platform team provide a base image for all of your teams. That's another possibility. It's still a good idea to take a peek under the hood and see what's actually in there so that you don't duplicate stuff and make it bigger than it needs to be. Now, I just wanted to explore around. I'm going to show you how to look at official images on Docker Hub, because it's still a good idea to take a look at it and see how they're built. So if I were to just Google for Docker official images here, we're obviously going to get all the documentation. If you scroll down a little bit, you should find a GitHub link. Here it is. Here's the Docker library. This is where all these official images are. This is where all the Docker files are. So just, this way you can see how the Docker files are built. They're all sitting here in this library folder. Let's look at Alpine. This is a common base image that's used. And the second line here, you see a repo, a Git repo. Now, all of these follow the same pattern. It's pretty well organized. So we want to go take a look at this repo. And within this repo, we get more information about how these are built. Some of these are different. Some have directories for different versions. This particular one has branches for different versions. Let's just take a look at version 3.16. Now we have different folders for architecture. We'll just pick the first one. And now we have a Docker file. So we can tell how this file was built. And this is a true base image, meaning it does not have a parent. That first line that says from scratch indicates that. We also know from this that there is a huge tar file that has been added to this image. So kind of hard to look at it. We know it's there, but this is how you can find out how images are built. I like doing this for images that are, maybe not just in OS, but stuff like, the JDKs, the JRE images, anything that we use for databases. I like to see how those are built, what their base images are, what their parent images are. So official images for Postgres, MySQL, all of those. It's a really good exercise to take just to be familiar with what is all going into your project. All right. As a junior Java developer, you can get pretty overwhelmed with all the choices out there for base images. In my particular case, I came from a Windows background. I was not really familiar with Linux, which was a struggle when it came to using Linux OSs, using those distributions for Docker images. So all of these names were foreign to me, Buster, Slim, Bullseye. Obviously, I recognized JRE and JDK. I could pull out versions. That was really helpful. But this isn't any magic. This is pretty straightforward. Turns out that these words, when you see them used for image tags, they actually correspond to variants of Debian. Helpful to know that. So if you know that your application has some compatibility issues with particular versions, you know right away what base images to avoid. Alpine is a little bit interesting. There are some good, they're not, I guess, official images, but I like using Azul's Zulu images for my JDK stuff. You'll see in this project I've been playing with OpenJDK, but note that if you go to the documentation on Docker Hub for OpenJDK, this has been deprecated. They recommend you use something else. So if you're using the flat OpenJDK images right now in your Dockerfiles, you really should be migrating to something else. All right, so I'm not just going to believe when someone tells me that images are better or that a particular base image is small. I'm actually going to build my project and find that out and take those measurements myself. So that's what I did. I noticed, right away, of course, JRE images are smaller than JDK. The ones that are labeled slim are even smaller. Although you might want to do some extra work with those, make sure you have a lot of test coverage, because there could be some problems with particular applications that you don't have the libraries that you need in slim images. So just make sure that your application requirements fit in order to use those. As far as analyzing the images, you can use Docker history. It's a pretty good way to kind of look at the commands that were used to build the images. Gives you a little bit of insight. Using the command line like this is a little bit annoying. You can't see the full command. You've got to mess with the columns that are showing, things like that. But you can dig in, and there are a couple of other tools that you can use. One that I found is called Dive. I really like this one. It's simple. You install it, and using your terminal, you use the dive command. You specify the image that you want to analyze and look at. And I can have some examples of what that looks like. It gives you a really good idea of the changes between layers. So you can kind of see, in this screenshot, we're sitting on the first layer on that left side. The first layer is highlighted. And we can even tell the size of that layer. We can see what instruction was used to create that layer. And I actually picked one of the images from the Spring Pet Clinic app and was consistent about what image I was looking at here. Then, as you move through the layers, you can tell what has changed. So there's a yellow color that indicates files and directories that have been modified. There's a green that indicates files and directories that have been added. It can be pretty revealing to see exactly how much you're adding to your image at each step. There's a little bit of frustration there as far as horizontal scrolling with this application, but you could certainly submit a fix for that. It's open for some help. One of the interesting things that I saw this application being used for is in a CI/CD pipeline. And it has an API. You can call it. You can ask about the change in image size. So let's say you have some threshold for developers to check in changes to a Docker file, and you need to make sure that the image doesn't just blow up out of proportion. And one way to do that and catch that early is just use a tool like this to measure it before accepting commits like that. can also indicate that there's something wrong that needs to be stopped earlier in the pipeline. There is, of course, Docker Desktop, the dashboard here. You can, images that are stored locally on your machine, that's your limitation there. You have to pull them down onto your machine to look at them. Not all of the items that are displayed here correspond to actual layers. It's pretty similar to that Docker history command. This is just the GUI version of it. But you can tell, the sizes, which commands are actually resulting in adding more layers to your image. It's a little bit more convenient to get the entire command. Some of these images are pretty creatively built, so being able to hit a layer and see the entire command that was used to build it is interesting to me. You can go down rabbit holes on this, of course, but I'm always into details like this. This one in particular was pretty fun to look at and parse through. And then just again, reiterating that your base images that you're using, make sure you know where it's coming from. Is it another image from another internal team that you're relying on? Is it from a public repo? There's more risk involved with that. Is it some random image off the street? I would not recommend going to Docker Hub and just picking whichever. You need to pay attention to if it's an official image. Do a little bit of research on it. Make sure that you understand the background of that image. Not everything there is trustworthy. This is on us to figure that out. So use the resources available to you to do a little more research on these images. One other thing to say about that, there's all kinds of scanning tools available too. There's a plugin for Docker Desktop that you can use that will scan these images for you. If you happen to be using a new one, you just want to check it out and see if there's any known vulnerabilities in there. Your CI/CD pipelines, you should have tools there that will scan your images as well. Some tie directly to your Docker registries that you're using. Make sure that you're utilizing all of those tools. It doesn't make sense just to do a security check once at the end. This needs to be a continual process in order to kind of, have a wide net in order to catch as many issues as possible. And also continuous scanning of images that are already in production, because new stuff comes out every day. And you are going to need to reevaluate your schedules and include time for upgrading your dependencies. We do this, or we should be doing this for our Java applications. We're going to need to do this for our containers as well, our images. Okay, so we know we can change our base image. From what we can see in the layer information, we can see that there's a pretty big difference in size potentially. So I wanted to stick with OpenJDK just for consistency. I knew it was an official image. Obviously, this isn't something I would put in production now, given that it's deprecated. But I did go looking to see what other tags they had available, and I landed on this version 11 JRE bullseye image. So I changed up my Docker file, and I built a new image. I liked that it was a JRE. That made me happy. And went ahead and built my image. I know you can't read that, but it's, at the end, you can take, just evaluate your images. I just ran the command to view my images and the sizes, and sure enough, there's a pretty big difference. So the first Docker image was using that full version 11. The second one, labeled Docker 2, is using the new JRE image that I found. So it looks like, almost half the size there. Already an improvement. You can't just be satisfied with that. You've got to go through the whole process. So all of your testing, anytime you make a change like that, go through the whole process with just that change. You don't want a ton of different variables involved, especially when you're changing out a base image like this, because who knows what problems it can come up with. There might be stuff in your application that won't work anymore because you don't have all of the resources that you need in this new base image. So you need to go through the entire process. Of course, my limited process here as a developer, just poking around, I just wanted to make sure I could still launch and run this application. Lots of other options for parent images. You can go hunting through Docker Hub and see what's out there. You can go to a lot of the vendors. If you have contracts with vendors, for example, for Java, for JDKs, it would make sense to use their images. Again, always bring those images in-house, though. Once you've got them, make sure that you're storing them in your own registries and not repeatedly pulling them from a third party. But one example that I thought was really interesting were distro-less images. Now, what I said earlier about making sure you don't have anything extra in your images that you don't need, one of those arguments is that you don't need a shell. You really don't. You shouldn't be execing into production containers running to troubleshoot. If you're doing that, there's bigger problems afoot. So I think this is a good argument. If you're not in a position where you could use a distro-less container like this that does not include a shell, you might want to evaluate some of your processes, some of your monitoring and troubleshooting processes in production. Google has some of these that they build. They use another tool called Bazel to build these. They're very specific on language types and what versions they support. I just put the 2 that they have available right now for Java. You have a choice of 11 or 17. So you're going to be a little bit limited there. You also have options to build these yourself. And packaged with Java 11, you have JLink. So you can identify the packages and the modules that are part of your application. Make sure that only those packages are being included in your base image. This is another example of how you can build an image with a Dockerfile and make it a little bit more efficient. You can split up the type of dependencies and the type of artifacts that you have into different layers. These layers correspond to how often they're updated. So think about if, a lot of the libraries we use, we hardly ever update because they're coming in, they're open source. The stuff that we modify all the time for our project, those need to be closer to the bottom of the Dockerfile. This means that nothing changes until it gets to your stuff that you're modifying, and only that layer is regenerated. So this helps with your build times. You can make your build times a little bit faster this way. Another option, so I've met a lot of developers who just don't want to deal with Dockerfiles and they would rather use other tools that are in place. One option for you is to use Maven plugins or Gradle plugins. I just want you to understand how that's actually working. In reality, those plugins by default are actually using cloud-native BUILDPACKS. These are great. They're very opinionated base images that you can use that get pulled in, but you need to understand that when you build these base images are actually being pulled in from another resource. So it would behoove you to find those images that are being pulled in by the BUILDPACKS and customize those, put those in your own registry so that at least to you, they're immutable and aren't going to change out from underneath you. That's some of the cons of BUILDPACKS. You do trade reading Dockerfile documentation and learning that for reading the plugin documentation, but if you're more comfortable with doing that, more power to you. Some links in here for BUILDPACKS. Paketo specifically is what the Maven plugin used. And again, I went ahead and built it and did some comparisons. And it turned out the BUILDPACKS was, a little bit smaller, but notice we now have 2 extra images in there. We've got Paketo BUILDPACKS Run and Paketo BUILDPACKS Builder. Those aren't going to end up in production, but those are being used to build your image. Jib, another method. This one you can actually use and not have to have a Docker daemon on your machine. Some really like that idea, not having to rely on Docker. You can just add the plugin. One thing it does, though, is it builds and pushes the image to your repo. That reduces the number of steps you normally have to take. But pay attention to the defaults. Some might not be what you expect. For example, distroless base image is a default for Jib. You can change that. I had some issues with accessing private repositories, so be ready to spend some time there. And I don't know that I like that it builds and pushes images. This feels weird to me in a development environment. Maybe if you have a registry that is specific for dev images, that's okay. But to me, it seems kind of a too early of a step to be pushing images when you're a developer just, making small changes. The last one, it cannot process run commands. So if you rely on some run commands in your Docker file, Jib isn't going to work for you. One example, or one modification you could make is have those run commands maybe already in a base image, and then you can use Jib from there. One option for you. Again, make sure you size them up. So I did that. I went ahead and built one with Jib. And it was interesting to see the results because it turned out 392 megabytes was Jib, which was very similar to the original build that I have with the JRE Bullseye. So always make sure you run these metrics at the end. It could be very different for your application, but don't always assume that one tool or one method is better than another. And last, I have some homework for you. The Spring documentation on this has improved immensely. I added links to that there, the one in blue. And there is a section in there on Gradle VM. So that will be my next journey, is figuring out how to use the native images with Gradle VM and see how that works out. All right, a couple more links. I can send these in my slides. Lastly, thank you for coming. Thank you for listening. This QR code, if you take this, it will bring you into a live tweet that gives you the option to say one thing that you learned during this session. That would be good feedback for me, and I'd really appreciate if you did that for me. Thanks.